want to tell you a little bit about some of the people who inspire me. These are students who had the bad sense to enroll in my spacecraft engineering course at Cornell University. These poor suckers and I went on an extraordinary journey over the last few years to build our own spacecraft and launch it. Times have really changed. I mean, this is, when I was in school, when I was an undergraduate, this was just not an option. Back in the mid-14th century sometime, when we used to build spacecraft out of pitch and wood and canvas, this was not a possibility. Technology has changed so rapidly, so much in the last couple of decades, that now even high school students are building their own spacecraft and launching them, and partly with NASA's help, but in fact you can get private launches for your spacecraft. It was about 2 years ago that I got one of these phone calls that makes you sort of sit up a little straighter and adjust your little suit coat, and if you're wearing a tie, you kind of adjust that. And it was a call from Charlie Bolden. He's the administrator of NASA. I now have the extraordinary opportunity to help NASA as serving as its chief technologist. I have a number of roles there, including deciding technology strategy, working on some of the largest scale spacecraft humanity has ever conceived. The International Space Station, which is up there now at any given time with 6 astronauts on board. It's an extraordinary opportunity to participate in something I've always wanted to do. And that's actually what these students want as well. And I have a feeling it's a lot of what you want to do as well. A lot of us feel these days a very personal, even intimate connection to technology, thanks to personal computers, cell phones, even smartphones. An expectation even that we can hold in the palm of our hand all the information of the world, that we're connected to everybody, and that in fact technology is usable. We get a little irritated when the menus change on our software products, because we expect it's a personal experience. What these students encountered, and what I've encountered over the years working with students, is just that. This notion of a personal experience with space. Now, as unlikely as that might sound, because we tend to think of space exploration as a very distant kind of activity, kind of far removed from our day-to-day experience. But I'm telling you, space is coming closer to us every day, and in an important sense, we're coming closer to it. At NASA, we have a number of investments right now in new ways of doing business. I'm going to tell you about one of them today, which is very connected to this overall idea of citizen space. So the message really is we can all be in space. It's a radical notion that in fact we could crowdsource space. We could actually ask the nation, even the world, to participate in space exploration in a way that, let's say back in the 80s, was really only possible through government agencies or maybe by large companies. We can all be in space. But why, am I as a government bureaucrat telling you about this today? It's a simple reason. There are problems that we need to solve, ways in which we can solve them that we have not yet exploited. Crowdsourcing is one of them. But as well, there's creativity that comes from individuals in this audience here, my students at Cornell, in fact, all over the world, that we're not taking advantage of if we keep space only the domain of a few folks or government agencies. By opening it up, we're going to make a lot more progress. There's also an economic argument to be made here. The fact is, when NASA invests in space technology, we're not spending that money in space. We spend that money right here on the ground. We spend that money on small businesses, large businesses, academia, and we develop the technologies whose innovations turn out to drive our lives and affect our lives every day. A quick example, so the camera in your cell phone, that's actually a CMOS technology that was developed at the Jet Propulsion Lab for Earth science. Now, what was once an expensive scientific instrument costs maybe $1 or $2, and you can put it in any device you like, and we have the ability to take pictures of anything, anytime. Another quick example, baby formula, infant formula. It turns out that about 95% of the infant formula sold worldwide now contains within it certain compounds, lipids, that were developed during the Apollo days for astronaut nutrition. But these same compounds turn out to promote brain growth and nervous system development in infants. So, you'll ask, isn't there a cheaper way to create baby formula than going to the moon? Yeah, there probably is, but that's not the point, right? The point is, when we take on these hard problems, naturally innovation happens. We end up solving problems that spin off, we call them, into every other part of our daily lives. Now just think if we take what NASA does and has done over the years and multiply it by all of you, the nation. Just think of the kind of innovation we'll see. Now, another economic argument to make is based on the fact that access to space right now is very expensive. Launch vehicles cost millions of dollars. It's thousands of dollars per pound to launch something into space. And that's changing slowly, but really for let's call it a casual or public use of space, we need orders of magnitude reduction in the cost to send something into orbit. So how do we address that? Well, it's a supply and demand question. It's a little backwards, though, for space access. It turns out that the more we use rockets, the more spacecraft we build, the less expensive they are. It's a little unusual, right? You'd think it would go the other way. But right now, there are a few rockets made a year. I think if GM only made a half dozen cars a year, they would not be as cheap as they are right now. So we can all be in space, and there's an economic argument for why it is that we should be investing as a nation in building this up. Some of us, maybe I'm the only one here, but I think some of us believe that our destiny lies among the stars, that we will someday become a spacefaring species. In fact, even in the nearer term, there are economic arguments to be made. If only we could find the killer apps for space. But I don't think I'm alone. Here's a picture of some folks watching a space shuttle launch. Thousands of people come from around the nation to Florida and around the world to watch space shuttle launches. In fact, I think the very last one was close to 500,000 people. It's an extraordinary outpouring of enthusiasm for what it is that we do as a species, exploring the cosmos. So at NASA, our notion is, can we harness this somehow? Can we, in fact, provide a sort of North Star, a direction, and pick a problem that's a hard one to solve that we all care about? Well, I think the answer is yes. And we started this some time ago. In fact, what I'm talking about now, this notion of citizen space or citizen science, is kind of a familiar one. Back in the late 50s, early 60s, they began something called Operation Moonwatch. In the Sputnik era, the request from the government was to all of the citizens of the nation, look up, tell us if you see a satellite. So nowadays, this is not a big deal, right? I mean, again, back in the early 14th century when I was in school, you could look up at the stars and see a beautiful sight, and every now and then, rarely, you'd see a spacecraft fly overhead. But these days, when I take my 7-year-old outside to go look at the stars or look at a meteor shower, he'll say, is that one? Nah, it's just another satellite. I mean, the sky is full of spacecraft these days. Operation Moonwatch brought together individuals in the nation with telescopes or just binoculars or whatever, the naked eye, to tell us where they found spacecraft. That worked great. It lasted for a couple of decades, in fact, one of the longest citizen science activities ever. But we found another problem that we think needs attention. And that's what's going on in this video right here. You'll recognize this as the meteor that almost impacted Chelyabinsk. This dash cam footage here is one of many images that capture this extraordinary event. Partly technology is the reason why we now have this footage. The ease with which we can take pictures and even live video of things is trivial. Even though this asteroid didn't in fact, or this meteor didn't in fact impact the Earth, it had a big impact, on the people of Chelyabinsk. 1,000 people were injured, lots of buildings damaged, glass broken everywhere, and it didn't even hit the ground. It exploded some distance above the ground. That thing was only, I don't know, maybe as big as this stage. It was not a big rock from space. There have been bigger ones. I'd say ask the dinosaurs, but you can't because of asteroids. You cannot ask them this, maybe other reasons as well. It turns out that these Earth-crossing asteroids or near-Earth objects are really pretty common. There are millions out there, of which we've discovered a number. Now, thanks to NASA and our partners worldwide over the years, we've discovered about 95% of the asteroids that are a kilometer or larger. And those are important ones. These are the ones that gave the dinosaurs a very bad day. These 1 kilometer asteroids, we know a lot of where they are because they're relatively easy to find. They're large, they're bright. We know about 60% of those that are, let's say, 300 meters or larger. And those are important, size of a football field. Those are, call them the continent killers. Clearly worth our attention, I think. We've got about 10% of those large enough to destroy a city, and really only a fraction of the millions that are out there of the Chelyabinsk size. And it may be difficult to find them all, but not impossible, I think, if we all pull together. So that's the nature of what this is about. We have what we call a grand challenge that we're rolling out for the entire nation. We are asking you to come help us, work with NASA to find all asteroid threats to human populations and know what to do about them. The first part is a science goal, if you like. And you think about it, the best defense for asteroids really is knowing where they are, assuming you don't have a Bruce Willis and a secret space shuttle to go send a nuclear bomb, which, by the way, is probably not the way to go. If you have several years of warning, it doesn't take much, maybe even a small satellite of the type that any of us could build, to go visit one of these asteroids and propel it just with a little puff of propulsion, just enough to nudge it out of the path of the Earth. So finding them is part of the problem. And even if you're not in the mood to build your own spacecraft, finding them might not be out of the realm of possibility. What we do right now as amateur astronomers, those of us who have telescopes, we get a telescope, we look up in the sky, and we take some pictures maybe, or we just look and enjoy that, and that's great. Let's say we were to crowdsource the problem of creating a little Bluetooth-enabled eyepiece that sticks on everyone's telescope, communicates images taken through cell phones or back to the internet into a single database. We would get terabytes, petabytes of imagery about the night sky. And just think of how we could mine that with today's technology. There are lots of ways out there that we can contribute through building software, hardware, observing the night sky, maybe even scanning in those old pictures that your uncle took of a meteor fall in Alaska back in the 60s. Whatever it would take, data that we can now use to understand the population of asteroids out there. This grand challenge is something that can motivate, I think, a lot of us to join with NASA. And just like the outsiders that my students and I once were, maybe some of you who would like to join with NASA to solve this problem can be motivated to do this. What other kind of problems could we solve if we all pull together, if we all adopt this notion of citizen space? Well, here's a great picture from Deep Space Industries. It's a company, one of several in fact, who have in mind mining asteroids. So the vision here is you put a 3D printer in space that somehow sucks up mass from an asteroid and spits out a space station. It's very science fiction-y, I know, but you gotta have some vision to get where you want to go. Seriously, though, there are lots of resources out in space. Asteroids are some of those. We would be looking for resources. There's science to be done. There's human exploration to be done. And let's not forget that NASA has in its plans sending a robotic mission to an asteroid in the next 4 or 5 years, followed soon thereafter in the early 2020s by a human mission to an asteroid. This is an exciting, audacious plan on the scale of Apollo. We'll be sending humans farther from Earth than they've ever been, for longer than they've ever been, doing some exciting science, all for a fraction of the cost of Apollo, even using some of the existing hardware that we have right now at NASA. But remember, there's also this do-it-yourself community, the so-called maker community out there, who wants to just make things, to be part of the technological world. Imagine if we had a 3D printer in space. Imagine one on the moon, imagine one on an asteroid. Just think of being able to create the space infrastructure that we would need to pursue the next generation of space missions, whether they're privately funded or done by individuals or done by NASA. That would be an incredible world. We have an opportunity, though. We can start now. We can start with the asteroid grand challenges, and I hope that you will come join us in this. Thanks very much.